So this video lesson is all about what it means to subtract with negative numbers, both how we do it and the reasons why we do it the way that we do. And much like the other video lessons that we've had so far with negative numbers, with absolute value, with ordering, and with adding, we're going to use the idea of temperature and thermometers to help us understand why things are the way they are. Now, if for some reason you haven't watched the adding with negative numbers video lesson yet, you need to go back and do that because some of the things we do are going to reference what's in that video. And again, we're going to use this blank thermometer here to talk about the movement of temperatures and let that lead us to why we subtract with negative numbers and how that operates. So let's look back at one of the problems from the last video with adding. It should be familiar. The temperature at midnight is -5 degrees. If at 3 a.m. it's 14 degrees cooler, what was the temperature at 3 a.m.? So go ahead and pause the video. Work through this again, either as an addition or writing it as a subtraction. And we're going to go through this and talk about how the addition way that we did it before is related to the way that we talk about and think about it as subtraction. So pause the video, work on that, and come back when you're ready to move on. So if we use the thermometer at the right to draw this, we'll draw the -5 nice and high on the thermometer there. There's -5, and we're getting 15 degrees cooler, so the temperature is going down, or 14 degrees cooler rather. Now in the last video we expressed that as -5, and then we were jumping another 14 degrees in the negative direction. So it's like adding another negative 14 degrees away from 0. We also said that we could write this as -5 degrees, and by getting cooler, we are taking 14 more degrees away. So we can express this problem and how we solve it in either one of these two equivalent statements. -5 plus -14, when we're talking about additional steps away from 0 in the negative direction, is actually the same calculation and results in the same answer as -5 minus 14. Now we know initially, because we've watched and worked with adding negative numbers, how to operate with -5 plus -14, and have found that that's -19, because they're taking steps in the same direction away from 0. We are now 19 degrees below 0. The same thing can be said of -5 minus 14. As we said, they're the exact same problem, but we can't think about it quite as the addition, but we think of -5 on the number line, and we drop 14 farther in the negative direction, which puts us 19 degrees away. Again, because if we start at -5 and continue 14 degrees in the negative direction, we're going to add those absolute values together. So we can write it in two different ways that will result in the same answer. Let's see if that same thing is going to be true when we look at the next problem here. The temperature at midnight is -3 degrees, and if at 3 a.m. it's 16 degrees cooler, what is the temperature at 3 a.m.? Try to think about it as we did the last one, as both an addition and a subtraction. Pause the video and come back when you are ready to move on. So here, we'll draw it the same way that we did before. We'll put -3 on the thermometer, and we're going to drop 16 degrees. So again, we're going to drop 16 degrees and get farther and farther from 0. Now, as a subtraction, we can call that -3, and then we are moving another 16 degrees towards the negative side. So we're actually losing 16 degrees from -3 degrees. And so as a subtraction, that's what it looks like. If we're looking at it as leaps backwards on a number line, that's the same as saying it's -3 plus -16, because we're starting at that -3, and then we're jumping another 16 degrees below 0. Just like the last one, since we're moving in the same direction on the number line, that is, we're adding numbers of the same sign, we're going to add 3 and 16 to get 19. So just like -3 plus -16, -3 minus 16, since they mean the same thing, are -19. And in both of these cases so far, we've noticed that the addition of a negative number has been the subtraction of that same positive number. It's happened with -14 and plus -14. It's now happening with -16 and plus -16. And that is not only significant when we're talking about temperatures, that's significant towards the definition of what subtraction really is. And so looking at that on a number line, particularly that last one, where we have -3, if we were going to represent -3 plus a -16, that's 2 jumps in the negative direction on the number line until we finally get to negative 19. Well, when we think about movement on a number line with subtracting away a 16, it's actually the exact same movement. And so the relationship between addition and subtraction here becomes very important. In fact, that's how we're going to actually go through and subtract, is by understanding the relationship between those two operations. And as we can see, when we subtract a 16 and we add a negative 16 and we get the exact same movement, there should be something significant about what's going on. And so the big question is, what does subtraction represent? Go ahead and pause the video and take a few seconds to think about different ways that you've heard subtraction represented and what it means. You can sketch them down in your notebook if you want, but you don't have to. You can just think about that, pause the video, and come back when you're ready to move on. And so one of the first ways that we hear about subtraction is taking objects away from a larger group. We start out with 15 apples, we eat 7 of them, we have 8 left. That's not really going to be helpful when it comes to working with negative numbers, because it's not a very physical quantity that we can work with that really makes negative numbers make sense. Another way that you might have heard about it is as distance on a number line. The difference between, say, 19 and 15 is equal, that's just a regular 15, is equal to the distance that they are away from each other on the number line. In that case, 19 minus 15 is 4, and they're a distance of 4 away on a number line. But what we're going to use for subtraction as a way of understanding it is as the inverse operation of addition. And that should make sense when we look back at our problems and we said that negative 3 minus 16 is the same as negative 3 plus negative 16. Here we are subtracting away a positive 16, and here we are adding a negative 16. So it seemed so far like when we are subtracting, we are actually doing the same thing as adding the opposite numbers. 16 and negative 16 are opposites. 5 and negative 5 are opposites. So if we're taking 16 away, it's the same thing as adding a negative 16. It's the same motion on a number line that we saw. The green one being subtracting a 16, and the red one being adding a negative 16. So let's see if we can figure out what that means with a negative number. So subtraction being the inverse operation of addition, meaning that they can cancel each other out, to put it in a little bit of an easy kind of way to say, but it doesn't really get at what inverses are. So if the inverse means to do the opposite of, and subtraction and addition are inverses, what does that mean if we're trying to say subtract a negative 14? Adding a negative 14 moves us one way on a number line. So pause the video for a second and think to yourself, if this is what adding a negative 14 does, what should subtracting a negative 14 look like? Well, we want adding and subtracting the same numbers to be opposite movements. So if adding a negative 14 moves to the left towards the negative side by 14 units, subtracting a negative 14, doing the opposite, the inverse, should move in the other direction. So in this case, moving 14 in the positive direction, which just so happens to be the same as adding a positive 14. So it seems like 25 minus negative 14 should be the same as 25 plus 14. That is, we imagine it as adding whatever the opposite number is. And that is exactly what subtraction with negative numbers turns out to be. We are going to add the opposite of the number being subtracted. Now, in technical terms, the number being subtracted is called the subtrahend. You may not have heard that before. I know I've said it in class. But the blue number here, the first number that is having something taken away from it with subtraction, is called the minuend. The red one is called the subtrahend. So go ahead, pause the video, and write down this process right here. To subtract integers, you add the opposite of the subtrahend. So what that means is that if we have 27 minus 37, we understand that subtracting 37, subtracting the positive 37, should move us towards the negative direction. Well, that's the same as adding a negative 37, because adding a negative 37 does the same thing. And since we know rules of addition, we're actually going to rewrite these subtraction problems as addition. So 25 minus 37 becomes 25 plus its opposite, which is negative 37. Then we can follow the rules which talk about the motion on a number line that we talked about in the last video to end up with negative 12. Now, if we're subtracting that negative number, like we just talked about, then it would be the same as adding a positive, because if adding a negative 37 moves us to the left, then subtracting it should move to the right on a number line towards the positive direction, which is the same as moving that 37. And we'll show it on some number lines as we get a little bit farther. So this is the process we're going to use. We're going to add the opposite of the number being subtracted. So what that means in this problem, 25 minus negative 14, is instead of subtracting a negative 14, we're going to add its opposite. That means our subtraction is going to become an addition, and our negative 14 is going to become a positive 14. Because again, on the number line, here's 0, here's 25. Adding a negative 14 would take us to the left, but we're not. We want to subtract it, which means we're moving in the opposite direction of that initial negative number, moves us to the positive direction, which is the same as adding 14. So 25 plus 14 then gets us to our final sum, which is 39. So now it's time for you to practice a little bit on your own. Remember, when we subtract, we're just adding the opposite of the subtrahend. So go ahead, pause the video, see what you can do with these. Even if you're not entirely sure, take a crack at it. We'll go through the answers, and then we'll have another 4 problems for you to look at after that. So in all of these cases, we're going to use the process of adding the opposite number. Negative 22 minus 15 is going to turn out the same, since here's negative 22, and we're taking away 15. That's going to turn out to be the same as negative 22 plus a negative 15. Now these two numbers are moving the same direction on the number line, 2 steps towards the negative, so their distance from 0 is only going to increase. We're going to add their absolute values. 22 plus 15 is 37. But we can't keep walking to the negative direction and ever get back to positive, so it is a negative 37. Moving over to the right here, we have 27 minus 17. Some of you might recognize that immediately as 10. If we rewrite that using the idea of add the opposite, then that's 27. And since subtracting a 17 moves us to the left on a number line towards the negative side, that's the same as adding a negative 17. So that's 27 plus negative 17. Again, or rather not again, these numbers are moving in different directions on the number line. So if we start 27 steps away, we're going to cancel out 17 of those steps as we get closer to 0. So we do 27 minus 17, which is 10. And since 27 has a greater value, it is a positive 10. Moving to the next one down here, again, this becomes negative 40. We're going to add the opposite of negative 55. Which means we're going to add 55, because taking away a movement to the left is the same as moving to the right. Here's negative 40, which I'll write here in green. Or maybe I will. Yeah, there we are. Negative 40. And now we're going to move 55 in the positive direction, which means we're going to end up passing 0. So we're going to cancel out some of that distance from 0. 55 minus 40 is 15, and we end up on the positive side because we take more steps towards the positive than we did towards the negative to end up with positive 15. And again, if we add the opposite, this becomes 42 plus a positive 17, which is just 59. Very familiar addition problem there. So now go ahead, pause the video again, work on these 4 problems, see what you can do, and come back when you are ready to see the processes and hear the answers. So admittedly, with a problem like the first one, 25 minus 18 is one that we can do just with our regular positive number operations. It is indeed 7, so if that's what you got, that's great. If we use it with this negative idea, it becomes 25 plus negative 18. We're adding the opposite of this number here, which again gets us to positive 7, because those two numbers are moving in opposite directions from each other on the number line. In the second one over on the right, 25 minus negative 18, the opposite of moving to the left 18 is to move to the right, so that's 25 plus 18, which is a very familiar 43 for us. For the one down in the bottom left corner, this becomes negative 25 plus negative 18. And now this is moving in the same direction away from 0 on the number line. There's negative 25 We're going to take 18 more steps that way. We're getting farther and farther away from 0, so our absolute value is getting larger and larger, which means we're going to add these two values. 25 minus 18 is 43, but because they're both negative and we're still on the negative side, that is a negative 43. And then finally, for the last one, adding the opposite kind of value becomes negative 25 plus 18. We're adding numbers of the opposite signs, so we have to subtract their absolute values, and we end up with a 7 when we take 25 minus 18. But since 25 is the larger value between 25 and 18, we will have taken more steps in the negative direction than towards the positive. So just like when we add negative integers, when in doubt, we're going to draw it out and put it on a number line to see what is actually going on. But the process that we use for our subtraction is basically to make it into an addition, because as they are inverse operations, we can identify subtraction as just adding the opposite of the subtrahend.